Welcome. Thank you so much for being here. Today we're going to talk about Argo Rollouts. We have Nick Morey here with us. Nick, will you introduce yourself, please?
Gladly. I'm Nicholas Morey. I come from a background in Linux system administration and then a little bit of DevOps engineering. And now I'm here in developer advocacy because I don't want to be on call anymore. I'd rather talk about the technologies and help educate other people. And I think that's the theme of today.
You haven't had any emergencies where people need to talk about, I need to talk about Argo Rollouts now. Yeah. Explain it to me on Sunday.
Hold the pager just for Slack ads. Yeah.
Well, I'm so excited you've taken some time to talk about Argo Rollouts with us now. And you and I just had a 2-hour-long conversation where we filled up this whole board. You taught me about Argo Rollouts. And now we're going to make a recap resource for those of y'all who have less time and maybe want to see a shortened version. But if you do want to see that long conversation, Nick and I are a lot of fun. If you do want to see it, we'll link to it in the description of this video. So Nick, let's get started with Argo Rollouts. We're going to do a lot of context. So the first piece of context I'd like for you to help me understand is, why does rollouts exist? Like, what problem is Argo Rollouts solving?
The key problem that Argo Rollouts is solving is that Kubernetes doesn't provide any built-in mechanisms to provide a controlled and gradual release of a new version when you make a change to, let's say, a deployment for this example.
So let's maybe even go as far as to digging in a little bit into what Kubernetes does do when you have a new deployment.
We've got our existing deployment. It's already generated the replica set that contains the template for the pods, and then it's generated pods based on it. Now we have a new version of our pod template. We've changed the container image from V1 to V2, and that generates a new replica set, which then starts rolling out new pods. The default deployment mechanism has two options. It can either recreate the pods, which tears down all the old ones before bringing up the new ones. This is really important for if you have an application that can't have two versions running at the same time. Or it can do a rolling update, which is the default mechanism, where it brings up a new pod for version 2 in the new replica set. And then once that's ready and available, it brings down one pod in the old replica set, and it continues this process going forward. But that's all the control that you get over the delivery of that new change, of that change to the deployment into the cluster.
So let's be really explicit about what the shortcomings are of doing it this way.
You get very little control over the subset of users that you expose to that new version. If you do that gradual rollout, you have one pod and 4 old pods, then you're naturally sending 20% of your traffic to the new version. But that's more of a consequence of how it's doing the rollout. You didn't explicitly state that I want 20% of my traffic to go to this new version. You don't have that level of precision. You also don't get a lot of control over the speed of that rollout. You can say how much you're willing to go above your desired number of replicas and how many replicas you're willing to have unavailable. But you can't say specifically, I want 5% of my traffic to go to this new version. You're stuck with whole numbers and kind of working around the limitations of services. And then you really don't have any sophisticated way to verify the success of that deployment. You can rely a little bit on readiness and liveness probes, but that doesn't take into account the information that your application is producing and sending to metrics or providers, to observability providers. You can't use that to determine success. And then in the event of failure, you have no mechanism for automatically rolling back the previous change. You ultimately just get stuck in the progression to the new replica set. You can't say, this failed, let's go back to the old replica set and stay there.
As part of the shortcomings, like this is a lot of shortcomings, and any one of these shortcomings might cause you to want to have a better process for rolling out new applications or rolling out updates to applications. And that better process, it has a name. And that name is called progressive delivery. So you taught me that progressive delivery is the process of releasing software and updates to software in a slow and gradual manner, therefore reducing risk. And then we talked about 2 deployment strategies that fall under this header of progressive delivery. And the first one is a blue-green deployment. What's a blue-green deployment?
A blue-green deployment is when you spin up a new version of your application alongside the old version, but you don't immediately expose that new version to the public or production traffic. It actually sits kind of alongside it in the background, allowing you to internally test and validate that deployment in the actual production environment. So it allows you to do integration testing without sending production traffic to that new version. And then at a certain point, once you're confident in that green version, you do a flip. You're basically flipping the switch to go to the other version. Typically, like at a load balancer, you would say, okay, I now want to send my traffic to green, no longer to blue. And then bam, everything is over on the new version. And then you leave the blue version up and running for a certain period of time to allow a quick rollback to that old version, maybe a scaled down version, maybe the full production version. And then that gives you that safe rollback opportunity. And then once you're sufficiently confident, you can scale down the old version.
That flip switch moment, the idea of it's making my heart beat fast even now, just thinking about it. So then another way to do progressive delivery is to do a Canary deployment. What's a Canary deployment?
The Canary deployment, you could say, is like the next level of progressive delivery from a blue-green. It takes this idea of having a old version and new version running alongside it, but it breaks it down into a more controlled rollout. So you're saying, I want to give the subset of users to my new version rather than flipping the switch all at once. So Canary deployments tend to go through a series of steps, starting at a really low weight or percentage of traffic being sent to that new version. And then you increase that percentage of traffic as you gain more confidence in that new version. As you see the results of sending 5% of your traffic, you're confident. Now let's move to 25% and repeat the process.
We have all of this context now. We understand how Kubernetes deployments work, like natively to Kubernetes. We understand what progressive delivery is and some strategies for doing a better job. And so now, what is Argo Rollouts?
Argo Rollouts is a controller and a set of CRDs that add the progressive delivery functionality to Kubernetes. It advances beyond what the standard deployment can provide.
And so to really explain what Argo Rollouts is, we talked about it through that lens of custom resources, and we dug into some custom resources. So the first one we talked about is a rollout. Now, what's remarkable about a rollout to me is a rollout is meant to completely replace the Kubernetes deployment, the deployment object. So we have a rollout instead of a deployment object. I have some questions. Is it hard to migrate from using Kubernetes deployments to rollouts?
It's not. It's explicitly designed to provide a safe mechanism to transition from your existing deployment to a rollout. You can either literally drop in, replace, change the API version, change the kind to an Argo rollout, or you can introduce a new Argo rollout resource that adopts or references an existing deployment and does the delivery, progressive delivery from the existing deployment resource to that new rollout resource.
Okay, I need to get that right out of the way, because that kind of the idea of switching, I feel a little attached to my Kubernetes deployment resources. So the idea of switching, I feel like should be addressed right off the bat. But then this rollout resource then adds the functionality of the blue-green deployment and the Canary deployment. Now I can do that in my rollout resource. So how does it work with blue-green deployments in your rollout resource?
What the rollout resource does for blue-green deployments is it adds in that functionality to manipulate not just the replica sets that are typically generated from a deployment, but also manipulate the services that direct traffic to those pods from those replica sets from that what was previously a deployment is now a rollout. And it provides the active service, which is where that flip is switched. That active service is the one choosing between blue or green. And then optionally, you can add in this preview service, which says, I have this green version. I'm not sending production traffic to it, but I can get to that green version and do my validation of whether or not it's stable, it's running correctly.
And then how exactly that validation is done, we'll get to shortly. That's coming. But before we talk about that, let's talk about what it means. How can we do a Canary deployment from within this rollout resource?
We mentioned earlier how a Canary is essentially the next evolution of a blue-green deployment. The rollout resource provides a list of steps that progression is going to go through when you're using the Canary deployment strategy. So you specify in these steps for the Canary deployment the weight, the percentage of traffic that you want to send to that new version. And you also specify how long you want to spend on that new version. You can tell it to pause for a certain period of time at the, say, 5% weight, or you could tell it to pause indefinitely at that new weight so that you can go and through manual intervention or through a separate automated process, trigger the progression to that next step in the Canary deployment. And then it continues through those steps for whatever weights or traffic percentage you specify until it's fully transitioned over to that new version.
So for both of these strategies, there are one or many points where you need to be like, hey, I want to make sure the deployment that I have running, I want to observe it. I want to analyze it. I want to test it. I want to make sure it is great before I either do the big switch flip or before I start sending more real production traffic to it. So how do we integrate that big decision or that analysis into the rollout?
So that's where the analysis template comes in, is that you can actually specify what testing that you want to run as you progress through your delivery strategy. Whether it's blue, green, or Canary, you can specify an analysis template that then reaches out to your observability providers, or you could run a Kubernetes job or make an HTTP request, and you specify based on those metrics, what is my success criteria? I want to see 95% successful status codes coming out from my application. That's what success looks like. And then that analysis template is used in the rollout to determine how to progress through that deployment strategy.
So if you're using a rollout, let's for example, we're using a rollout to define a Canary deployment. How might I use an analysis template to say, yes, this is successful, I'm ready to move on to the next step?
In a Canary deployment, you could put a reference to this analysis template in line in that step of the Canary deployment. And then it would then trigger an analysis run based on that analysis template. It would do the actions specified in the template. So call out to my observability provider, bring in those metrics, run them through my success criteria, and then the analysis run will complete with criteria. And that criteria could be success, failure, or inconclusive. And the rollout uses that information to determine how to move forward.
Or backwards.
Yes. Yeah. So if we're successful, the rollout knows to move forward. If we fail, that's that automated rollback that the standard deployment is missing. It can actually tell it to scale back to the old replica set. And then the really fun one is when you get an inconclusive result, which is just a natural possibility when running analysis or doing testing. You might get an inconclusive result. And at that point, it'll actually pause the rollout and wait for that manual intervention.
We don't have this on the board, but do you want to talk briefly how an analysis run can either be part of a step or it can be continuously running in the background?
Definitely. So if we use the Canary deployment as a deployment strategy as our example here, we can think of as we go down the steps, we're progressing down a road. And as we go down the road, each step in it is an intersection where we have to make a choice. And when you reach that intersection, you have your stoplights, and the analysis run is that stoplight telling you if you're successful, you've got the green light, continue on to the next intersection, the next step within your Canary deployment. If we get a failure, that's our red light that tells us to stop and start backing up down the road, I guess, following the analogy. And then that inconclusive is that yellow light where we're not quite sure how we should progress. And that's when somebody has to come tell you whether or not you're allowed to continue driving down the road. Maybe it's more like a construction worker with a yield sign and you're not sure what to do. Yeah. So that's inline. You're running down the street, you're going through the intersection, and your analysis run is your stoplights. For inline, you can also run it in the background, which essentially is running it alongside the Canary steps that you're going through. On the side, it's going through the analysis, determining if it's getting the correct results. You're meeting your success criteria as you go through it. And so it's kind of like having a cop parked alongside the road, checking the speed. And if you're failing to match the expectations of the road, it's actually going to stop you no matter which intersection, no matter which stop that you're at or a step that you're at in your Canary deployment. And it can fail you there and back you out.
So if it's inline, it will only speak when spoken to, when you ask it a question. And what's the other one called?
Background.
If it's background, it might interrupt you at any time.
Exactly.
So then we talked about advanced traffic management and how Argo Rollouts integrates with the service meshes.
This adds that extra layer on top of doing simple analysis and doing simple weight-based traffic management, where you're saying, I want 5% to go to my new version. With the traffic management functionalities, you can actually integrate into service meshes to do more advanced techniques, like header-based routing, where you can say, if in my request to my application, I see this specific payload, this header that says that I'm running Firefox on macOS, you can tell that traffic to go to the new version rather than just a 5% sample of the entire traffic base. Another big example is traffic mirroring, where you can say, this is really big on blue-green deployments, I find, where you can actually send a copy of your traffic to both deployments. And your blue version is going to be the old version, which actually returns the response to your user, where the green version still receives the traffic, but the response from the green version doesn't get relayed out to the user. And instead, you're running analysis on how your green version is behaving as you're mirroring the traffic to it.
So this solves the problem we talked about before about the Kubernetes services not being pretty coarse-grained in terms of how much traffic you can send to any one of them and how you send that traffic. Yeah. I have a couple of questions. One is, do you think you could quickly give an example of how all of this works together? Like an end-to-end rollout description?
Yeah, let's see if I can do it quickly. Let's say I've got a new version of my application that I want deployed into my Kubernetes cluster. I'm already using the rollout resource, and I have 3 Canary steps. I've got 5%, 50, and 100. It's really coarse, but we have safeguards in place as we progress through it. So I change my version of my application, my version of my deployment, and it gets deployed into the cluster. To clarify there, actually, I'm changing the version of, say, the container image on my rollout, not my deployment resource. That gets deployed into the cluster. The rollout responds to that and says, creates my new replica set, spins up new pods, and starts delivering 5% of the traffic to my new pods. I have an inline analysis template configured for that step in my Canary deployment. It's going to create an analysis run that calls out to Prometheus and pulls in metrics related to my application and determines success. My analysis run completes successfully, so I move on to the next step in my Canary deployment. I'm now at 50% of my traffic is being served to my new version. And so at this point, we rerun maybe a different analysis template, but for this example, let's say we're rerunning the same analysis template. I want 99% successful for my metric that I'm pulling from Prometheus. But now that I'm serving to 50% of my users, I'm actually starting to see a bunch more errors. I've hit a new subset of users that I didn't get in my initial 5% sample. And my analysis run ends up failing because I haven't met the success criteria for the failure limit of, say, 3 times. This signals to the Argo rollout that it should actually stop and abort that rollout and do a rollback to the previous replica set. It spins down the replica set that has the new version. All the traffic is now being served to the original old version, and the rollout enters a degraded state.
That's fascinating. And I love that it happens automatically. One benefit of just not bothering people, like, of course, you're going to do a postmortem and figure out what happened, but in the moment, there's not super stress. But it also minimizes the number of users that get exposed to the faulty application. I do have a couple more questions still. One is, before our conversation today, when I hear Argo, the big thing I associate it with is GitOps. Does GitOps relate to this?
Yeah, you can think of GitOps as the delivery of the new desired state, and you can think of Argo Rollout as progressing that new desired state into the live state. So you make a change in Git, Argo CD syncs that into your cluster, and it modifies the desired state in Kubernetes. You're actually updating etcd, and now Kubernetes is trying to deliver that change to the compute nodes, to where the pods are running. Argo Rollouts is the controlled progression of that new version of the desired state, really the new version of the live state, into those pods, actually into production. They aren't necessarily required to go together because they have that clear distinction of in Kubernetes versus outside Kubernetes. You're making a change into, and then now you're actually running it. But they work pretty well together.
So they work well together, but they can be completely separate too. Exactly. They don't need one another. And then my last question is, where can I go to learn more?
Yeah, I highly recommend checking out the documentation. It's very thorough in its examples and its explanation of the concepts that are important to understand. As you can see, half the board is conceptual, half of it is actually practical. And that's because you need the context to be able to understand the rationale and the impact that you're going to have by implementing it. And then as you go through the documentation and maybe you get stuck, or maybe you're looking for other people's experience, I highly recommend checking out the Argo Rollouts Slack channel on the CNCF Slack workspace. And there are a ton of community members, maintainers, and just general experts that hang out there and are just super happy to be helping anybody that's interested in implementing this.
I used to be shy about the Slack channels, but now I understand that people love that they've been making this technology and they're very excited to share it, and they're excited to answer questions.
It's like being shy to talk to the presenter at a conference, but when you realize that they're there because they love talking about this thing, when you go up and ask them a question, just like in the Slack channel, you're likely going to be met with eagerness and happiness to help.
A warm and welcoming community. I love it. Well, is there anything else you'd like to say in conclusion? Do you feel like we covered everything?
I feel like we have. Yeah, I think this is definitely enough to get people getting running with Argo Rollouts. There are a ton of nuances, and as you reach those nuances, definitely reach out for help because people have gone through it too.
Well, thank you so much for taking the time to share your valuable time and your expertise with us today, Nicholas.
Yeah, thank you for having me. It's been an honor to create this resource.
Awesome. And thanks everyone who watches the recording all the way to the end. See you next time. Goodbye.